This video will continue to discuss the two-factor analysis of variance, and we'll go for some specific examples to help you understand those main effects and the interaction. So here's the example that we've been discussing, but previous videos we've only seen just the word means in these different boxes. So now what I've done is I've gone to a table from the actual paper, and I've taken the numbers for self-esteem. So this is one of the dependent variables that they measured. So here's my factor B, ostracism versus inclusion. Those are my two levels of factor B. And here is my factor A. Here's the two levels under one level of factor B. Here are the other two levels for factor A under. So it's just a different way of presenting this information because they have multiple dependent variables. So for the in-group that was ostracized, I put that mean here. For the out-group that was ostracized, I put that mean here. For the in-group that was included, that mean went here. And for the in-group that was out-group that was included, that mean went here. And then I have the total means. So if we look here, again, this is factor A group type. If we look at the overall means, the column means, we aren't concerned with what's going on in here because we want to look at the main effect of factor A regardless of what social interaction they had. Was there an effect, an overall effect of group type? And if we look here, 4.47, 4.17, sure, in-group is a little bit higher, but they're very, very close. And if we were to then go up and look at standard deviations, we would see that there probably is no main effect for group type. Now, to look at the main effect for social interaction, again, we're going to compare the row means, the overall means. Because again, we're not concerned about what's going on here. We want to know, does social interaction have an effect regardless of the group type? So we have an overall mean, which is just the, because of equal ends, it's 3.57 plus 3.3 divided by 2. This mean comes from 5.37 plus 5.17 divided by 2. And we compare these row means to see if there's a main effect of social interaction or factor B. Now looking at and comparing these means, so again, statistically, you would do an analysis comparing these overall means, and you would get an F ratio for these row means, and you would get an F ratio for these column means. And then you'd compare that F ratio to your critical F and determine. Again, we're not doing calculation, so we're just going to look at these means and say, is there a difference? There does appear to be a pretty big difference. The group that was included had higher self-esteem than the group that was not included. Now again, we would have to do a statistical test to see if it was significant, but I can tell you from looking at the paper, they did the test and it was significant. So here we had a main effect for social interaction, but not a main effect for group type. So that whether you're ostracized or included, remember ostracized means kind of outcast. So the groups that were included, people that were included in the text messages had a higher self-esteem than those that were not. Group type did not appear to have an effect, whether they were in the in-group or the out-group. And then for an interaction, we look at these means. So we look at the differences here. So here, between these two, we have a 0.27 difference. And between these two, we have a 0.2 difference. So looking at the differences between in-group and out-group, dependent on ostracism versus inclusion, not a whole lot of difference there. If we look at the differences here, we see a 1.8 point difference and a 1.87 point difference. So again, the differences between ostracism, the ostracized group and the included group doesn't differ much based on whether they were in an in-group or out-group. So most likely there would not be a significant interaction there. So now I'm going to take you to an example where there is a significant interaction. So this is a new study where a set of researchers examined individuals in high-contact sports like football and ice hockey and low-contact sports. The goal was to study the effect of repeated head injuries. The dependent variable was a performance on a conceptual thinking task, and a group of athletes in contact and non-contact sports were examined before and after the season started. So, how many factors are in this study? We have factor A, which is sports. And so here I've changed factor A now is on the rows and factor B is on the columns. So we have one factor here. We have a second factor here. Do we see a third factor? So we have one factor, which is sport. We have another factor, which is time. So we have two factors in this study. Now, how many levels are in each? So for sports, I see contact, no contact. And for time, so that's 2. For time, I see before and after, which is also 2. So I have 2 factors, each with 2 levels. So that makes it a 2 by 2 factorial Anova. So now let's look and see if we think we see a main effect. So for a main effect for factor A, remember factor A now is in the rows. Are we going to look at these means? No, because these means are dependent upon the other factor. Here we're going to look at our row means. So for factor A, we're going to look at our row means. And we're going to compare, and we see that regardless of the time, before or after season, non-contact sports, people in the non-contact sports scored higher in that conceptual thinking task than those in the contact sports, suggesting there probably is a main effect. Or potentially. Now, for factor B, I'm going to change the colors here. Factor B is time. So for factor B, we're going to look at the column means. Again, we wouldn't look in here because these means for time are dependent on the type of sport. We want to say, regardless of the type of sport, does time make a difference? Are conceptual thinking scores different before and after the season? And what we see is before the season, conceptual thinking scores were higher than after the season. So regardless of the type of sport, we see a decrease in conceptual thinking scores after the season. Now, that doesn't really necessarily make any logical sense. Why would conceptual thinking scores decrease? Unless the sport had something to do with it. So here, this would be where we look for our main effect of B. So now we want to look and see, is there an interaction? So that's where we look at these means. So if we look before and after the season in contact sports, we see a 5-point difference. If we look before and after the season in non-contact sports, we only see a 1-point difference. So this difference we see here is really due to changes before and after the season in our contact sports. If we look at the differences before the season in our contact and non-contact sports, we see 0 change. If we look at the difference before and after the season, contact and non-contact sports after the season, we see a 4-point difference. Again, suggesting that the differences we see here between our contact and non-contact sports are due to whether it's before the season or after the season. We don't see a difference between contact and non-contact before the season, but we see it after the season, suggesting that this difference depends on whether the timing, whether it was before the season or after the season. We don't see a difference before season, but we see one after the season. So the type of the effect on conceptual thinking for sport depends on time. And here's a graph just kind of showing you this. Here's that conceptual thinking task. Here's before and after. It's a crude graph, but it's a graph nonetheless. And here's this showing you for the white line would be the non-contact sport, which I have. That's why I have it here highlighted in white. And you see before and after, you don't see much of a change, a 1 point difference. But for the contact sport, the black line, we go from a score of 9 down to a score of 4 in that conceptual thinking task. And this is much like what you would see for an interaction graph, is that the lines somehow converge. So they're non-parallel lines. They cross, they converge, or they diverge. Whereas for the previous example, we would see parallel lines. So here's the ostracized group around 3, going down slightly, and here's the inclusion group up at 5, going down slightly. And see how they're parallel. They're not converging, they're not crossing. So when we have main effects without an interaction, often we see these parallel lines. And we can also see that there's this main effect for social interaction because this line is higher than this line, but not much of a main effect, probably not significant, for group type because these lines aren't sloping very much. And this here is just again to re-emphasize the interaction. So here again, we don't see a difference before the season. So it's a little bit better of a graph. It's got some numbers on it. So from before the season, before and after the season, so non-contact, contact. So for the non-contact, we go down just 1 point. But for the contact sports, we go down 5 points. Again, the lines are converging, suggesting an interaction. Here's another, a little bit more complicated example. So how many factors are in this example? We see direction that they're traveling, and we see subway stations. So there's 2 factors. One is direction, traveling west or traveling east, and the other is which subway station they're in, Spadina, St. George, Lorient, or Sherborne. How many levels do we have of each one? So for direction, we see up here, it's listing 1, 2. So we have 2 levels for one of the factors. Down here, we see 1, 2, 3, and 4. So for subway station, it has 4 levels. So how would you write this out? It is a 2 by 4. And it doesn't say anything here, but I'll tell you that it was between subjects. Different individuals were in each of those conditions.